Today we're going to talk about circles. Tomorrow you will need your books in class. Okay, tomorrow you're going to need your books in class, so make sure at least 2 people at your table probably have a book, probably each here. Okay, so if you need to arm bustle, figure out who's going to bring it, just do whatever you need to do. Today we're going to talk about circles. Circles is by far my favorite topic because everything starts to come together with circles. You're not going to see it all today, but we have a whole chapter on circles that sometimes can be like 3 weeks long because there's just so much that goes into it. The triangles are so important to circles. Quadrilaterals are so important to circles. And it's one of those mathematical aha moments where you're like, oh, that's why that happened. Okay? So if you haven't had many of those in your lifetime, I feel like circles is where it all kind of comes together. And as you get older in math, and as you get further along, you have more of those, oh, okay? And they're kind of fun. Keeps me out a little bit. That's right. All right, so circles. We're going to do some basic terminology today. We're going to do a little bit with calculations. But again, this is just an introduction to circles. So first of all, let's define what a circle is. So a circle is the set of all points in a plane at a given distance from a given point. Okay, so what it means is this black outline that we call a circle is really just an infinite number of points that is the exact same distance that we call a radius away from a point which we call the center. Okay, so that radius, no matter where we draw it, is going to be the same length because all these points that make that circle, that black circle, are the exact same distance apart from that center. Okay, that's by definition what a circle is. To name a circle, we name it according to the center. So in this case, the center is named B. This is referred to as circle B. So you make a circle, you put a dot in it, and you put the letter B. Capital B, because it's a point. We also need to talk about parts of the circle. So an arc is called, or an arc of a circle are the 2 points and the continuous part of the circle between them. Okay, so we have 3 types of arcs: minor arcs, major arcs, and semicircles. So let's start with a minor arc. A minor arc is named with 2 points. It's the start and the stop of the arc, basically. So AD, we refer to this arc right here that I highlighted. A minor arc is going to measure between 0 and 180 degrees. So it's going to measure between 0 and 180 degrees. Does not include 0, does not include 180. A major arc is named using 3 points. It's kind of like a road map. So this says major arc DAP, starts at D, goes towards A, ends at P. So DAP would look like this. That's major arc DAP. Okay, so because it's a major arc, it's going to measure between 180 degrees and 360 degrees. So major arcs have to have 3 points to name them. Minor arcs have to have 2. Finally, we have what's called a semicircle, which means halfway around. So half of 360 is 180 degrees. So it equals exactly 180 degrees. So in our case, it says ADP, so it tells me start at A, then go to D, then go to P. We could have also gone around the other way, but I don't have a point named over there on that bottom half. So typically, semicircles are named with 3 points. Your book is sometimes bad about giving you 3 points for a semicircle. They'll only put 2 to try to trick you. so that you're not automatically reading that it might be 180 degrees. Okay? But typically semicircles are named with 3 points. The little arc above the point, that is the arc symbol. So that way we know we're talking about, like if I were to say arc AB versus the segment AB, we'll talk about. Okay. Questions about major arc, minor arc, or semicircle? All right. The next thing we need to talk about is the measure of an arc. Okay, the measure of an arc is equal to the value of the central angle that opens to that arc. So first of all, central angle is an angle. Think about central angle. The vertex is on the center. So it's an angle whose vertex is on the center of the circle. We think about the angle in terms of being a mouth. The arc that it intercepts is called the intercepted arc. So BC here is the intercepted arc of this angle, I didn't mean the center, but of this central angle. Okay, the measure of the central angle and the measure of the arc are the exact same thing. Okay, so the measure of the arc is the exact same as the central angle. So if I were drawing another angle here at 120 degrees, let's say this was 120 degrees, the arc would be another 120 degrees. Does that make sense? I didn't mean to make it look like such a straight line there. But nonetheless, the central angle and the arc measure are equal. So if the central angle measure and the arc measure are the same, let's think about if I were to add angle 1 plus angle 2 plus angle 3 together, how many degrees would I have there? 360 all the way around, which is why all of my arcs added together are also going to equal 360 degrees. That's probably not a big surprise to you, but I'll try to make some connections here. All right, what I'm going to do is I'm going to give you a couple minutes. I want you and your table group to look at the next 2 slides. Okay, you're going to be looking for arc measures and angle measures in the next 2 slides. So maybe I'm going to give you 2 minutes to look at it by yourself. So I'll tell you when that 2 minutes is up, and then I'll let you talk to the table group about it. Sound good? All right, so go ahead and look at it yourself, and then I'll tell you when 2 minutes is up. Well, if not, I got a lot of card stuff. Stick out. Yeah. Okay, guys, go ahead and talk about as a people group if you haven't started already. I'll bring you down. All right, did you have enough time to talk about it as a group? Hold on, guys. Let's check on your math. Hold on for a second, please. Are you guys? Anyone need more time? All right, so on this first problem here, what I notice is these three angles together make a straight line, which means how many degrees are they going to be? Total of 180. So that tells me that if I were to take 25x plus 3x plus 2x, that should equal 180 degrees, right? Okay, so that gives me a total of 30x, if I combine my like terms, equals 180. Therefore, x has to equal 6. Okay, now you can go back and plug all those in if you want. So 25 times 6 would give me 150. 3 times 6 is 18. 2 times 6 gives me 12. And then we can answer our questions. So what is the measure of angle AOD? 150 degrees. Good. Now it says, what's the measure of angle AOE? So AOE is this angle right here. So a couple ways to think about it, and this is one of the reasons I love geometry, is I could first look at a different color here. I could look at this angle right here. These two together make a linear pair. So I know 180 minus 150 would have to equal this angle, right? So 180 minus 150 gives me 30. Okay, another way I can look at this is this angle right here, these two angles together, my 18 and my 12, that adds up to be 30. They're vertical angles to this angle here. So it's another way to see it. Is that okay? So your answer here should be 30 degrees. Questions on that? All right. Next problem says find the measure of each arc. So you have a couple things labeled over there. With circles, if they label a point in the center here, it's typically the center of the circle. Okay, so this is circle O. So I know then that this is going to be a semicircle. I know this is going to be a semicircle. If this is 32, I know this has to be 32. I like to find all my arc measures and then answer my questions. But I think it's easier sometimes. So if this is 180 and I take away 32, what do I get? 148. If this is 180 and I take away 58, that gives me 122. Are we okay? All right, so now let's answer our questions. We want to find BC. BC, that's 2 points. It's a minor arc, so it's the shortest distance between B and C. So that's going to be 32 degrees. Is that okay? All right, BD. From B to D, again, the shortest distance because there's only 2 points. That's 32 plus 58, which gives me 90 degrees. Good. ABC, that's 3 points. So that means it's either got to be a semicircle or a major arc. So ABC ends up being our semicircle. So that is 180 points. 180 degrees. Next one, arc AB. Again, the shortest distance. So we already have that labeled. That has to be 148. And then finally, BAD. BAD. So start at B, then go to A, and then go to D. So really, I want everything except this 90 degrees that we had up here. So what do you get? 270 degrees. Good. Questions on that? Okay, I want to give you a couple more terms dealing specifically with circles. The first one is called a chord. Okay, it's not misspelled. In geometry, we spell chord as C-H-O-R-D. Okay, so a chord is a line segment whose endpoints lie on the circle. When we say on the circle, we're talking about the black line that we use to represent the circle. Okay, so these 3 are all chords. On the blue over here, these are not chords. Okay, so we have 3 chord examples here. The problem with this one is this endpoint lies outside of the circle. This point is not on the circle. This is on the center of the circle. So on the circle literally means the black right here. Sound good? All right. The next term is called a diameter. So I know you've probably heard of this term before, but a diameter is a very specific chord. It's a chord that passes through the center of the circle. It's also the longest chord in a circle. So this makes for a good always, sometimes, never question. Okay, so always, sometimes, or never. A diameter is a chord. Always, by definition, it's a chord, right? What if I reverse that? A chord, no, yeah, a chord is a diameter. Sometimes a chord is a diameter, right? This chord is the diameter, but these 2 are not. Does that make sense? Good. All right. Next term is called a tangent line. You may have heard of tangent lines when you were in Algebra 2, maybe. Sometimes you do work with parabolas, and you draw on the tangent to the point on the parabola. Did you do anything with that? Maybe some of you sounds familiar. Okay. So we have tangents for circles as well. The idea is the same. Okay. So it is a line that intersects a circle in exactly one spot. It only intersects once. Sometimes it'll be a segment that we use, but it just barely touches the circle and only intersects at one point. So in this figure here, my tangent line is named AB. And point B is referred to as the point of tangency. Yes, you're good. So point B is called the point of tangency. So that point where the line and the circle intersect. All right. Next thing I want you to do, I'm going to give you literally 1 minute. I want you, for this figure, to name the circle, name at least one radius. You can name as many as you want. Name the chord, name the diameter. Okay, so I'm going to give you 1 minute to take a look at this. It's circle with dots. RC, good. How about radius? Give me a radius. RC, or it could be CR, right? The order does not matter. Second, what else? CN, CQ, CP, and CO. All of those are radii. Good. How about a chord? What are our chords up here? R, P, and O. Good. All of those are sections. And then finally a diameter. RP. RP is the only diameter. Good. Okay, so for your homework, and worksheet for you for your homework, on the front, the front was very quickly, the back of all the ones that were out front, the calculations, the front is pretty straight.